Hello, I'm Rex Childhouse, and I was exposed to 3D printing in August of 2021 by Travis Good at the San Diego Fine Woodworkers Workshop. I took the course very shortly after that. I bought the Pressa i3 Mark III S Plus, I think it is, 3D printer. Totally in favor. It's a super printer, and I've done a lot with it. And going over to thingiverse.com, thingiverse.com, and downloading stuff or trying to create stuff with a couple of the 3D generation applications like Fusion 360. Having fun with this thing, and my wife is keeping me busy. One of the things I like to do is I like to make educational stuff that my granddaughter, Princess Lily Bean of Candyland, educationally grows from. And I'm not sure how I got this. I got this link. I think I typed in toys on Thingiverse as a search tool, and it came back. What it is it's a watch escapement desk toy. That's what it's labeled. It's Thingiverse number 3364860, and it's by LarkysPrints. To give him credit, and I'll give him credit. And I'm going to show you more detail in action, but this is the guy. And when you wind him up and you start him working, he works like a watch. So there's some issues with him, and part of that's because of the filament I'm using, the precision of the printer, and whatever else. We're going to show you more of this. We're going to show you in action. This is absolutely super. It takes 20 files and 23 prints because the bases are one file, but you need 4 of them. There's well over 50 hours of printing time in this, and there is some issues with it. It's built for metric, and there's some conversions that other people have done to it to bring it to whatever you want to call it, imperial, fractional, US standard, whatever. I highly recommend you try one of those. The hardware for this cost me more than $20 in metric, and I compared one item. It was 79 cents for one bolt in metric, 19 cents if I went to very similar size in US standard. I highly recommend you go over to the US standard side if you're in the US. If you're international, metric's probably a lot cheaper. We're going to show you this in motion a little bit better and talk about it. It's a really cool print, just a very long print, 50 plus hours. 20 files, 24 prints to get this done. Let's go over and watch it work. We're on my dining room table, and I've got the watch escapement desk toy set up for us, and identify some things with it. This is referred to as a mainspring, and underneath it there's a ratchet and the ratchet gear. And when you wind this guy up with this key, can't wind him up too much. PLA is flexible, but not that flexible. I've already broken one mainspring. If it wasn't controlled in some manner, this would just zing, unwind like a tape measure that's not being held. Then it comes through some gears to kind of slow it down. It comes up to this guy here, and this guy here is working off a spring over here, and you're going to see it go flip-flop. So this is what controls the release of the tension of the potential energy of this spring as this goes back and forth. Some comments on construction. I have no idea what this particular piece is supposed to do. I've had it engaged and in position, and haven't found a use for it, haven't found a need for it. So I haven't found a use for it. It doesn't engage, and it doesn't seem to matter. And it might be, and I'm guessing, just logic, since this stops any rotation. Either way, doesn't matter, but I mean it could go backwards, and that would stop it, I guess, from going backwards. I'm not sure. It doesn't engage. Save yourself half an hour printing time. As I said, this is a 50 plus hour printing on my Pressa i3 Mark III S Plus, And these are all the same, so this is one file you have to print 4 times. I printed it in various colors so that it stood out instead of blending in and making things visible. So what you do with this guy is wind him up a bit and then start his spring working. And I'll wind him up a little bit more and let's see if we can get him going here. And we're working with PLA, we're working at high friction, so he doesn't work perfect, but he does demonstrate how this whole system works. And this guy here, as he comes this way, he stops the forward motion. The spring back here, this hairspring, then retracts him and allows the lower portion of this to engage and stop the wheel. So it can only move, theoretically, one increment, one tooth at a time. Out of the default construction, I had to file this guy down like 1/4 of an inch in order to get this to work. And it's probably because using PLA, the hairspring back here to operate this lever isn't all that good. So let's see what happens. And there are some adjustments, and I've had to make them. These stop this arm from moving up and down and how far it can go. And that's about the only adjustment that seemed to do anything with me. Back here, I'm going to move them. There's an adjustment here to center this. I played with it. It's close. I'm not sure how close it is. It's the closest I've got. And let's see what happens. It does a good job of showing how a wind-up watch works. And I'm blaming it on PLA spring tension as the reason that it doesn't work better. So it does work, and it's kind of cool. Let's flip it around. We'll wind it up again and we'll flip it around. Oh, okay. Stop. Hey, that was a pretty good run. Overall, this is one of the more fun things I've made off of Thingiverse. My wife wanted to know why I wanted to make it, and I want to show the bean how a wind-up watch works. And I have a couple of wind-up watches around here. A customer client, when I was doing consulting, gave me a really expensive wind-up watch. I never wore it. I had a Casio Databank watch on my wrist at the time, giving me all sorts of telephone numbers and names and whatever else. Really cool toy, really cool device, especially if you want to learn how this thing works. As I said, there's 20 files. You have to print 23 items. The bases being one file you have to print 4 times. And this is metric by the designer. It's metric. There are some conversions to imperial, if you want to call them imperial. I learned them as US standards, fractionals. There is a conversion to taking it to US standard number 8s type things. I put this in metric. It was more than $20 in hardware. There are a couple of issues with the lengths of some of the screws. The screw back here in particular, this screw, dropped the key again. This screw in particular, by the bill of materials, the BOM, is too long. It interferes with this gear, so I had to go and get a shorter one. And I think it does like to work. This screw here was way too long, and I just updated it. I printed it in various colors so that it was attractive, whatever else. You can print it all in one color if you want. I wanted the visual distinction. Really cool. I appreciate the individual that designed this and put this up on Thingiverse. I thank him for that. It's a great thing. And my My criticisms are just time to print and quality of the springs, probably because of the PLA filament issues. And it's a lot of fun. I thank the designer for putting it up on Thingiverse. A pretty cool device, really. And Princess Lily the Bean of Candyland, my granddaughter, loves to watch it. Loves to wind it up and make it work. Kind of fun. And to give credit where credit is due, this is a LarkysPrints off Thingiverse, and on Thingiverse it is 3364860. A super print.